Today I am discussing about the most important chapter of science class 9th, from which minimum 2 say 3 questions are asked in every exam, so it is most important. So let's start without wasting of time. Chapter number is 3, Atoms and Molecules. Chapter is Ancient Indian and Greek philosophers have always wondered about the unknown and unseen form of matter. The idea of divisibility of matter was considered long back in India. Around 500 BC, an Indian philosopher, Maharshi Kanad, postulated that if we go on dividing matter, padarth, we shall get smaller and smaller particles. Ultimately, a stage will come when we shall come across the smallest particles beyond which further division will not be possible. He named these particles Parmanu. Around 500 BC, an Indian philosopher, Maharshi Kanad, postulated that if we go on dividing matter, padarth, we shall get smaller and smaller particles. Ultimately, a stage will come when we shall come across the smallest particles beyond which further division will not be possible. He named these particles is Parmanu. Okay. Another Indian philosopher, Pakadhwa Katya Ma, elaborated this doctrine and said that these particles normally exist in a combined form which gives us various forms of matter. Around the same era, ancient Greek philosophers Democritus and Leucippus suggested that if we go on dividing matter, a stage will come when particles obtained cannot be divided further. Democritus called these individual particles atom, meaning individual. All this was based on philosophical consideration and not much experimental work. To validate these ideas could be done till the 18th century. Okay. By the end of the 18th century, scientists recognized the difference between elements and compounds and naturally became interested in finding out how and why elements combine and what happens when they combine. Okay. Antony L. Lavoisier laid the foundation of chemical science by establishing two important laws of chemical combination. Law of chemical combination. The following two laws of chemical combination were established after much experimentation by Lavoisier and Joseph L. Proust. 3.11 Law of conservation of mass. Is there a change in mass when a chemical reaction takes place? Activity. Take one of the following sets X and Y of chemicals. X 1 copper sulfate, Y sodium carbonate. In X, second barium chloride, Y sodium sulfate. X third lead nitrate, Y sodium chloride. Prepare separately a 5% solution of any one pair of substance listed under X and Y, each in 10 ml in water. Take a little amount of solution of Y in a conical flask and some solution of X in an ignition tube. Okay. Hang the ignition tube in the flask carefully see that the solution do not get mixed. Okay. Put a cork on the flask. See figure 3.1. Here is a cork, thread to hang a tube, conical flask, a small ignition tube, solution of X, solution of Y. Ignition tube containing solution of X dipped in a conical flask containing solution of Y. Weigh the flask with its contents carefully. Now tilt and swirl the flask so that the solution X and Y get mixed. Weigh again. What happens in the reaction flask? Do you think that a chemical reaction has taken place? Why should we put a cork on the mouth of the flask? Does the mass of the flask and its contents change? Okay. Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Next, law of constant proportions. Lavoisier, along with other scientists, noted that many compounds were composed of two or more elements, and each such compound had the same elements in the same proportions, irrespective of where the compound came from or who prepared it. In a compound such as water, the ratio of the mass of hydrogen to the mass of oxygen is always 1:8. Whatever the source of water, in a compound such as water, the ratio of the mass of hydrogen to the mass of oxygen is always 1:8. Whatever the source of water. Thus, if 9 gram of water is decomposed, 1 gram of hydrogen and 8 gram of oxygen are always obtained. Similarly, in ammonia, nitrogen and hydrogen are always present in the ratio of 14:3 by mass. Whatever the method or the source from which it is obtained. This led to the law of constant proportions, which is also known as the law of definite proportion. This led to the law of constant proportions, which is also known as the law of definite proportion. This law was stated by Proust as, in a chemical substance, the elements are always present in definite proportion by mass. The next problem faced by scientists was to give appropriate explanation of this law. British chemist John Dalton provided the basic theory about the nature of matter. Dalton picked up the idea of divisibility of the matter, which was till then just a philosophy. He took the name atoms as given by the Greek and said that the smallest particles of the matter are atoms. His theory was based on the law of chemical combination. Dalton's atomic theory provided an explanation for the law of conservation of mass and the law of definite proportions. Here is important fact about John Dalton. John Dalton was born in a poor weaver family in 1766 in England. He began his career as a teacher at the age of 12. 7 years later, he became a school principal in 17 1893, Dalton left for Manchester to teach mathematics, physics, and chemistry. In a college, he spent most of his life there teaching and researching. In 1808, he presented his atomic theory, which was a turning point in the study of matter. Okay. According to Dalton's atomic theory, all matter, whether an element, a compound, or a mixture, is composed of small particles called atoms. According to Dalton's atomic theory, all matter, whether an element, a compound, or a mixture, is composed of small particles called atoms. The postulates of this theory may be stated as follows. First, all matter is made of very tiny particles called atoms, which participate in chemical reaction. Next, atoms are individual particles which cannot be created or destroyed in a chemical reaction. Next, atoms of a given element are identical in mass and chemical properties. Next, atoms of different elements have different masses and chemical properties. Okay. Next, atoms combine in the ratio of a small whole number to form compounds. Okay. The relative number and kinds of atoms are constant in a given compound. You will study in the next chapter that all atoms are made up of still smaller particles. What is an atom? Question is that, what is an atom? Have you ever observed a mason building walls? From these walls, a room and then a collection of rooms to form a building. What is the building block of the huge building? What about the building block of an ant hill? It is a small grain of sand. Similarly, the building block of all matter are atoms. Okay. How big are atoms? Question is, how big are atoms? Atoms are very small. They are smaller than anything that we can imagine or compare with. More than millions of atoms, when stacked, would make a layer barely as thick as this sheet of paper. Okay. Atomic radius is measured in nanometers. 1 by 10 to the power 9 meter बराबर 1 नैनोमीटर. 1 मीटर बराबर 10 to the power 9 nm nanometer. Relative size read in meter. Example, atom of hydrogen 10 to the power minus 10, molecule of water 10 to the power minus 9, molecule of hemoglobin 10 to the power minus 8, grain of sand 10 to the power minus 4, ant 10 to the power minus 3, apple 10 to the power minus 1. We might think that if atoms are so insignificant in size, why should we care about them? This is because our entire world is made up of atoms. We may not be able to see them, but they are there and constantly affecting whatever we do. Through modern technique, we can now produce magnified image of surface of elements showing atoms. Here, figure 3.2, an image of the surface of silicon. Okay. Next, what are the modern day symbol of atoms of different elements? Here symbol of atoms of different elements. Okay. Dalton was the first scientist to use the symbol for elements in very specific sense. When he used a symbol for an element, he also meant a definite quantity of that element. That is one atom of that element. Okay. Berzelius suggested that the symbol of elements be made from one or two letters of the name of the element. Berzelius suggested that the symbol of elements be made from one or two letters of the name of the elements. Here symbol of hydrogen, symbol of carbon, symbol of oxygen, phosphorus symbol, sulfur symbol, iron symbol, silver symbol, lead symbol, copper symbol, gold symbol, platina symbol, mercury symbol. Figure 3.3 symbol for some elements as proposed by Dalton. These symbols proposed by who? Dalton. In the beginning, the names of elements were derived from the name of the place where they were found for the first time. For example, the name copper was taken from Cyprus. Okay. Some names were taken from specific colors. For example, gold was taken from the English word meaning yellow. Know a day. IUPAC, International Union of Pure and Applied Chemistry, is an international scientific organization which approves names of elements, symbols and units. Okay. Many of the symbols are the first one or two letters of the element name in English. The first letter of a symbol is always written as a capital letters, uppercase, and the second letter as a small letter, lowercase. The first letter of a symbol is always written as a capital letters, uppercase, and the second letter as a small letter, lowercase. For example, hydrogen, H, aluminium, Al. Here A is capital and L is small. Cobalt, CO. Here CO is CO, C is capital and O is small. Symbol of some elements are formed from the first letter of the name and a letter appearing later in the name. Example are 1. Chlorine, Cl, zinc, Zn, etc. Other symbols have been taken from the names of elements in Latin, German or Greek. For example, the symbol of iron is Fe from its Latin name ferrum. Sodium is Na from natrium. Potassium is K from kalium. Therefore, each element has a name and a unique chemical symbol. Passage of time and repeated passage you will automatically be able to reproduce the symbols. Atomic mass. Okay. The most remarkable concept that Dalton is atomic theory proposed was that of the atomic mass. Dalton is atomic theory proposed was that of the atomic mass. According to him, each element had a characteristic atomic mass. Their theory could explain the law of constant proportion so well that scientists were prompted to measure the atomic mass of an atom, since determining the mass of an individual atom was a relatively difficult task. Relative atomic masses were determined using the law of chemical combination and the compounds formed. Let us take the example of a compound carbon monoxide CO, here both in capital letter, carbon and oxygen. Carbon monoxide CO formed by carbon and oxygen. It was observed experimentally that 3 gram of carbon combines with 4 gram of oxygen to form carbon monoxide CO. In other words, carbon combines with 4 by 3 times its mass of oxygen. Okay. Suppose we define the atomic mass unit, earlier abbreviated as AMU, but according to the latest IUPAC recommendation, it is now written as U, unified mass, as equal to the mass of one carbon atom, then we would. Here, symbols of for some elements. Element symbol: aluminum Al, argon Ar, barium Ba, boron B, bromine Br, calcium Ca, carbon C, chlorine Cl, cobalt Co, copper Cu, fluorine F, gold Au, hydrogen H, iodine I, iron Fe, lead Pb, magnesium Mg, neon Ne, nitrogen N, oxygen O, potassium K, silicon Si, silver Ag, sodium Na, sulfur S, uranium U, zinc Zn. The above table is given for you to refer to whenever you study about elements. Do not bother to memorize all in one go. With the assign carbon an atomic mass of 1.0 U and oxygen an atomic mass of 1.33 U. However, it is more convenient to have these numbers as whole numbers or as near to a whole numbers as possible. While searching for various atomic mass unit, scientists initially took 1 by 16 of the mass of an atom of naturally occurring oxygen as the unit. This was considered relevant due to two reasons. First, oxygen reacted with a large number of elements and formed compound. This atomic mass unit gave masses of most of the elements as whole numbers. Yes, okay. However, in 1961, for a universally accepted atomic mass unit, okay, carbon 12 isotope was chosen as the standard reference for measuring atomic masses. One atomic mass unit is a mass unit equal to exactly 1/12 the mass of one atom of carbon 12. Carbon 12 isotope was chosen as the standard reference for measuring of atomic masses. One atomic mass unit is a mass unit equal to exactly 1/12 the mass of one atom of carbon 12. The relative atomic mass of all elements have been found with respect to an atom of carbon 12. Imagine a fruit seller selling fruits without any standard weight with him. He takes a watermelon and says, this has a mass equal to 12 units. 12 watermelon units of 12 fruits mass units. He makes 12 equal pieces of the watermelon and finds the mass of each fruit he is selling relative to the mass of one pieces of the watermelon. Now, he sells his fruits by relative fruits mass unit FMU as in figure 3.4. A. Watermelon. B. 12 piece. C. 1/12 of watermelon. D. How the fruit seller can weigh the fruit using pieces of watermelon. Okay. Similarly, the relative atomic mass of the atom of an element is defined as the average mass of the atom as compared to 1/12 the mass of one carbon 12 atom. Atomic masses of few elements: hydrogen atomic mass 1, carbon 12, nitrogen 14, oxygen 16, sodium 23, magnesium 24, sulfur 32, chlorine 35.5, calcium 40. Next, how do atoms exist? Question is that how do atoms exist? Atoms of most elements are not able to exist independently. Atoms forms molecules and ions. These molecules or ions aggregate in large number to form the matter that we can see, feel or touch. Atoms of most elements are not able to exist independently. Atoms form molecules and ions. These molecules or ions aggregate in large number to form the matter that we can see, feel or touch. Next, what is molecule? A molecule is a group of two or more atoms that are chemically bonded together. A molecule is in general a group of two or more atoms that are chemically bonded together, that is, tightly held together by attractive forces. Okay. A molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence and so all the properties of that substance. Atoms of the same element or of different elements can join together to form molecules. A molecule can be defined as the smallest particles of an element or a compound, okay, that is capable of an independent existence and so all the properties of that substance. Atoms of the same element or of different elements can join together to form molecules. Molecules of elements. The molecules of an element are constituted by the same type of atoms. Molecules of many elements such as argon, helium, He, etc. are made up of only one atom of that element. Molecules of many elements such as argon, Ar, helium, He, etc. are made up of only one atom of that element. But this is not the case of the most of the nonmetals. For example, a molecule of oxygen consists of two atoms of oxygen, and hence it is known as diatomic molecule O2. Okay. If three atoms of oxygen unit into a molecule instead of the usual two, we get ozone O3. Yes. The number of atoms constituting a molecule is known as its atomicity. Let's repeat it. Molecules of many elements such as argon, helium, etc. are made up of only one atoms of that element. But this is not the case with the most of the nonmetals. For example, a molecule of oxygen consists of two atoms of oxygen, and hence it is known as a diatomic molecule O2. If three atoms of oxygen unit into a molecule instead of the usual two, we get ozone O3. The number of atoms constituting a molecule is known as its atomicity. Okay. Metals and some other elements such as carbon do not have a simple structure but consist of a very large and indefinite number of atoms bonded together. Metals and some other elements such as carbon do not have a simple structure but consist of very large and indefinite number of atoms bonded together. Let us look the atomicity of some nonmetals. Atomicity of some elements. Type of element name atomicity. Nonmetal argon monoatomic, helium monoatomic, oxygen diatomic, hydrogen diatomic, nitrogen diatomic, chlorine diatomic, phosphorus tetraatomic, sulfur polyatomic. Next, molecules of compounds. Atoms of different elements join together in definite proportion to form molecules of compounds. Atoms of different elements join together in definite proportion to form molecules of compounds. Few examples are given in table 3.4. Molecules of some compound. Compound combining elements, ratio by mass. Water H2O, hydrogen and oxygen. Ratio by mass is 1:8. Ammonia NH3. Combining elements, nitrogen and hydrogen. Ratio 14:3. Carbon dioxide CO2, carbon and oxygen. Ratio by mass 3:8. Here is the activity. Refer to table 3.4 for ratio by mass of atom present in molecule and table 3.2 for atomic masses of elements. Find the ratio by number of the atoms of element in the molecule of compound given in table 3.4. The ratio by number of atoms for a water molecule can be found as follows. Element, ratio by mass, atomic mass, mass ratio atomic mass, simplest ratio. element H, ratio by mass 1, atomic mass 1, mass ratio by atomic mass equal to 1 by 1 बराबर 1, simplest ratio 2, element is O, ratio by mass equal to 8, atomic mass U equal to 16, mass ratio by atomic mass equal to 8 by 16 equal to 1 by 2, simplest ratio is 1. Thus the ratio by number of atoms for water is H ratio O. Hydrogen ratio oxygen is 2 ratio 1. Next, what is an ion? Compound composed of metals and nonmetals contain charged species. The charged species are known as ions. Compounds composed of metal and nonmetal contain charged species. The charged species are known as ions. Ions may consist of a single charged atoms or a group of atoms that have a net charge on them. An ion can be negatively or positively charged. A negatively charged ion is called an anion and the positively charged ion as cation. Okay. Take for example sodium chloride NaCl. Its constituent particles are positively charged sodium ions Na plus and negatively charged chlorine ions Cl minus. A group of atoms carrying a charge is known as polyatomic ion. Table 3.6 we shall learn more about the formation of ions in chapter 4. Some ionic compounds. Ionic compound constituting elements ratio by mass. Calcium oxide, calcium and oxygen ratio by mass equal to 5 ratio 2. Magnesium sulfide, magnesium and sulfur 3 ratio 4. Sodium chloride, sodium and chlorine 23 ratio 35.5. Next, writing chemical formula. Okay, the chemical formula of a compound is a symbolic representation of its composition. The chemical formula of different compounds can be written easily. For this exercise, we need to learn the symbols and combining capacity of the elements. The combining power or capacity of an element is known as its valency. The combining power or capacity of an element is known as its valency. Valency can be used to find out how the atoms of an element will combine with the atoms of another element to form a chemical compound. The valency of the atoms of an element can be thought of as hands or arm of that atoms. Okay. Human beings have 2 arms and an octopus has 8. If one octopus has to catch hold of a few people in such a manner that all the 8 arms of the octopus and both arms of all the humans are locked, how many humans do you think the octopus can hold? Represent the octopus with O and humans with H. Can you write a formula for this combination? Do you get OH4 as the formula? The subscript 4 indicate the number of humans held by the octopus. The valency of some common ions are given in table 3.6. We will learn more about valency in the next chapter. Okay. Name and symbol of some ions. Valency, name of ion, symbol. Non-metallic element, symbol. Polyatomic ions, symbol. Valency 1. Sodium, symbol Na+, potassium K+, silver Ag+, copper Cu+. Magnesium Mg2+, calcium Ca2+, zinc Zn2+, iron Fe2+, copper 2 Cu2+, aluminium Al3+, iron 3 Fe3+. Here Mg2+, it shows that 2 plus is 2 valency. Aluminium 3+, it shows that 3 valency. Okay, just like sodium Na+, so valency is 1. Okay. Non-metallic element symbol. Hydrogen H+, hydride H-, chloride Cl-, bromide Br-, iodide I-, oxide O2-, sulfide S2-, nitride N3-. Polyatomic ions symbol. Ammonium NH4+, hydroxide OH-, nitrate NO3-, hydrogen carbonate HCO3-, carbonate CO3 2-, sulfite SO3 2-, sulfate SO4 2-, phosphate PO4 3-. Some elements show more than one valency. A Roman numerals show their valency in a bracket. Got it? The rules that you have to follow while writing a chemical formula are as follows. First, the valency of charge on the ion must balance. Next, when a compound consists of a metal and a non-metal, the name or symbol of the metal is written first. When a compound consists of a metal and a non-metal, the name or symbol of the metal is written first. For example, calcium oxide CaO. Here calcium is a metal. Sodium chloride NaCl. Sodium is a metal here. Iron sulfide FeS. Iron is a metal here. Copper oxide CuO. Copper is metal here. etc. Where oxygen, chlorine, sulfur are non-metal and are written on the right, whereas calcium, sodium, iron and copper are metals and are written on the left. Okay. Next, in compounds formed with polyatomic ions, the number of ions present in the compound is indicated by enclosing the formula of ion in a bracket and writing the number of ions outside the bracket. In compounds formed with polyatomic ions, the number of ions present in the compound is indicated by enclosing the formula of ion in a bracket and writing the number of ions outside the bracket. For example, MgOH whole twice. In case the number of polyatomic ion is 1, the bracket is not required. For example, in case the number of polyatomic ions is 1, the bracket is not required. For example, NaOH. Okay. Next, formula of simple compounds. The simplest compounds, which are made up of two different elements are called binary compounds. Valency of some ions are given in table 3.6. You can use these to write formula for compounds. While writing the chemical formula for compounds, we write the constituent elements and their valency as shown below. Then we must cross over the valencies of the combining atoms. For example, formula of hydrogen chloride, symbol hydrogen H, chlorine Cl, valency 1 1. Okay, formula of the compound would be HCl. Next, formula of hydrogen sulfide, symbol is hydrogen and S. Here hydrogen valency 1, sulfur valency 2, but formula is H2S. Okay, formula of carbon tetrachloride, symbol is carbon and chlorine. Here valency is carbon is 4 and chlorine valency is 1, but formula is CCl4. For magnesium chloride, we write the symbol of cations Mg2 plus first, followed by the symbol of anions Cl minus, then their charges are crisis crossed to get formula. Okay. Next, formula of magnesium chloride, symbol Mg, magnesium chloride Cl, charge chlorine 1 minus Mg2 plus, but formula is MgCl2. Thus in magnesium chloride there are two chloride ions Cl minus. For each magnesium ion Mg2 plus, the positive and negative charge must balance each other and the overall structure must be neutral. Okay. Note that in the formula the charge on the ions are not indicated. Here MgCl2 magnesium chloride. In magnesium chloride there are two chloride ions Cl minus. For each magnesium ion Mg2 plus, the positive and negative charge must balance each other and the overall structure must be neutral. Note that in the formula the charge on the ions are not indicated. Some more example. A formula of aluminum oxide, symbol aluminum Al, oxide O, charge is aluminum 3 plus and oxide 2 minus, but formula is Al2O3. Got it? Next, formula of calcium oxide, symbol calcium Ca, oxide O. Here charge is calcium 2 plus and oxide 2 minus. Okay. Here the valency of the two elements are the same. You may arrive at the formula Ca2O2, but we simplify the formula CaO, calcium oxide, in last. Calcium oxide, symbol Ca, calcium oxide O, calcium charge 2 plus, oxide 2 minus. Here the valency of the two elements are the same. You may arrive at the formula Ca2O2, but we simplify the formula as CaO, which is formula of calcium oxide. Got it? Next, formula of sodium nitrate. Symbol sodium Na nitrate NO3, charge Na 1 plus NO3 1 minus, but formula is NaNO3, is called sodium nitrate. Next, formula of calcium hydroxide. Symbol, the formula calcium Ca hydroxide OH, calcium charge Ca2 plus OH 1 minus, formula is CaOH whole twice. Note that the formula of calcium hydroxide is Ca bracket OH whole twice and not CaOH2. It is wrong actually. Got it? Calcium hydroxide, calcium symbol Ca, hydroxide OH, charge Ca2 plus OH 1 minus, formula is CaOH whole twice. Okay. Note that formula of calcium hydroxide is Ca bracket OH whole twice and not CaOH2. It is wrong actually. CaOH2 is wrong. We use bracket when we have two or more of the same ions in the formula. Here, the bracket around OH with the subscript 2 indicates that there are two hydroxyl OH group joined to one calcium atom. In other words, there are two atoms each of oxygen and hydrogen in calcium hydroxide. Next, formula of sodium carbonate. Sodium Na, carbonate CO3 minus, Na 1 plus charge, carbonate CO3 2 minus charge. Formula is Na2CO3. Okay. In the above example, brackets are not needed if there is only one ion present. Okay. Let's see again. Formula of sodium carbonate. Symbol, formula sodium Na, carbonate CO3 minus, Na 1 plus charge, CO3 2 minus charge. In the above example, brackets are not needed if there is only one ion present. Okay. Next, formula of ammonium sulfate. Formula ammonium NH4 sulfate SO4, NH4 charge 1 plus, SO4 in charge 2 minus. Formula is NH4 whole twice SO4. Got it? Next is some questions. Now we will discuss about molecular mass. Molecular mass. In section 3.22, we discussed the concept of atomic mass. This concept can be extended to calculate molecular mass. The molecular mass of a substance is the sum of the atomic masses of all the atoms in a molecule of the substance. The molecular mass of a substance is the sum of the atomic masses of all the atoms in a molecule of the substance. It is therefore the relative mass of a molecule expressed in a atomic mass unit. It is therefore the relative mass of a molecule expressed in a atomic mass unit. Here is an example. 3.1. Calculate the relative molecular mass of water H2O. B. Calculate the molecular mass of HNO3. Solution. A. Atomic mass of hydrogen is 1U, oxygen 16U. So the molecular mass of water, which contains 2 atoms of hydrogen and 1 atoms of oxygen, equal to 2 into 1 plus 1 into 16 equal to 18U. Next, the molecular mass of HNO3 equal to the atomic mass of H plus the atomic mass of N plus 3 into the atomic mass of O equal to 1 plus 14 plus 48 equal to 63U. Here the atomic mass of H is 1, the atomic mass of N is 14 and the atomic mass of O is 48. So then calculate it. I got it 63U. Now I will discuss about formula unit mass. The formula unit mass of a substance is a sum of the atomic masses of all atoms in a formula unit of a compound. Formula unit mass is calculated in the same manner as we calculate the molecular mass. Unit of a compound. Formula unit mass is calculated in the same manner as we calculate the molecular mass. The only difference is that we use the word formula unit for those substances whose constituent particles are ions. For example, sodium chloride, as discussed above, has a formula unit NaCl. Its formula unit mass can be calculated as 1 into 23 plus 1 into 35.1 equal to 58.5U. Okay. Example. Next. Calculate the formula unit mass of CaCl2. Solution. Atomic mass of Ca plus 2 into atomic mass of Cl equal to atomic mass of Ca equal to 40 plus 2 into atomic mass of Cl equal to 35.5 equal to 40 plus 71 equal to 11U. Okay. Now we will discuss about what you have learned. During a chemical reaction, the sum of the masses of the reactant and products remains unchanged. This is known as the law of conservation of mass. Next, in a pure chemical compound, elements are always present in a definite proportion by mass. This is known as the law of definite proportion. Next, an atom is the smallest particle of the element that cannot usually exist independently and retain all its chemical properties. Next, a molecule is the smallest particle of an element or a compound capable of independent existence under ordinary conditions. It shows all the properties of the substance. Next, a chemical formula of a compound shows its constituents element and the number of atoms of each combining elements. Next, clusters of atoms that act as an ion are called polyatomic ions. They carry a fixed charge on them. Next, the chemical formula of a molecular compound is determined by the valency of each element. Okay, next. In ionic compound, the charge on each ion is used to determine the chemical formula of the compound. Got it? This is important for all exams. Okay. So here is my class is end up. Thank you for watching this video. Hope you will understand some new things. Thank you so much.